Hello all, welcome back to this EduMoon tutorials. In this series of videos, let us discuss about the subject called Design and Analysis of Algorithms, also called as DAA. So, where this is a very important subject for the second years as well as third years in the current semester. And in this series of videos, I'll go with the techniques, basic design techniques for algorithms. So, I'm actually not going with the introduction part, that is fundamentals of algorithms and problem types. Which is I think already covered by the students. So mostly the techniques are important. So since the time is very short, within this as a short series of videos, I'll be covering the techniques. So the different techniques that we discuss in this subject are: the first one is the brute force technique, which is the simplest technique of all, and the next one, divide and conquer approach, which is very important for any designing of algorithms, mostly used. And the next one is decrease and conquer technique. So this is also a slight variation of the divide and conquer approach, but it has interesting variations in that, like decrease is constant, decrease with the variable size, and decrease with the constant factor also. And the next one is transform and conquer. And according to the syllabus for the current BTech students, there are too much chapters for their syllabus for the examination part. So those are space and time trade-off, and the last one is dynamic programming. So this is what the techniques we study according to the syllabus for the second year, third year students for the upcoming examinations. So today we discuss about the first technique, that is brute force technique. So coming to this technique, brute force technique is a very straightforward approach in problem solving. So it goes according to the definition of the given problem. So the examples we see under this technique are basically we see some sorting algorithms, searching algorithms, and some graph problems or else the geometrical problems in this one. So from the examples from the brute force technique, the examples taken are: first one is sorting, where we discuss about the two sorting techniques that we already studied in the data structures, that are bubble sort and the selection sort. So coming to the searching techniques, we have the searching of linear search, or also called as sequential search, and then string matching algorithm, which is a brute force string matching. So we discuss with the string matching algorithm, and then the closest pair and convexal problems, which are regarding these geometry problems. Then finally we go with the exhaustive search, where we discuss the different problems here, like the traveling salesman problem, simply written as TSP, and the knapsack problem, and the assignment problem. So these are the problems that we discussed in exhaustive search using the brute force technique. So straight away we go with the discussion of the sorting of numbers using the brute force technique. So let us first discuss about the bubble sort technique. So the very first algorithm we study in sorting the numbers is bubble sort, which is the simplest to implement also. So sorting technique is nothing but we'll be given a set of numbers in an array, and we need to arrange them in either ascending or descending order. So here let us take an example with some random numbers like 5, 3, 7, 1, 6 and 4 in an array. So let us take these 6 numbers and sort them using the bubble sort technique. So in the straightforward approach, what does the bubble sort do is, it will just compare the first two elements, that is 5 and 3, and check whether they are in the output order or not. That is, let us assume that we are doing this sorting for the ascending order. So it will check the order for these two elements, the first two elements 5 and 3. So if they are in the correct position, it goes to the next, or else it will swap those two numbers. So if it swap this 5 and 3, so the numbers will be in the next iteration, it will be like 3 and 5 after swapping those two numbers. Then it will check the next two numbers, that is 5 and 7. So it compares the second and third elements now, that is 5 and 7, and check the order. So already 5 and 7 are in the correct order. So there is no swap operation here. So it goes to the next elements, next two elements, that is the third element and the fourth element. So it checks the number 7 and 1 in the third and fourth position there. So again they are not in the correct order according to the ascending order. So it will generally swap those two elements like this, 1 and 7. Then it again goes to the next two elements, that is the fourth and the fifth element, that is 7 and 6. So when it compares these 7 and 6 elements, so already the 7 is greater than 6. So again there is a swap operation here. So 6 and 7 will be swapped in that way. And finally it compares the last two elements, that is 7 and 4. Again checking the order for the ascending order for these. 7 and 4 not in the correct order, so it swaps again that 7 and 4. So finally 7 will be in the last position. So this is the first iteration. This is the first iteration after swapping all the numbers. So the highest element 7 will be in its position. So the numbers actually we have taken are 537164, but after swapping you can see that the highest element 7 is in the last position. This is the first iteration. So after repeating the same iteration for the second time again, so now the next highest number will be in the last but one position. So you can easily guess that 5 will be in the position number 5 in that list. So after swapping this one, after the second iteration, so this will be the result after the second iteration. That is, you can see the last two elements are in the sorted array. So the highest two elements 6 and 7 are in the end of the list. So after the third iteration, again performing the same operations what we have done in the first and second iterations, that is comparing the first two elements and so on, it will swap the numbers and you can see that the last highest number will be in its position, and this is the resulting array after the third iteration. Similarly, there will be 3 more iterations, but actually got the answer here itself because we have taken the random numbers. For example, if you take completely reverse order numbers like 5, 4, 3, 2, 1, for each iteration, that is after 5 iterations you get the correct output, that is 1, 2, 3, 4, 5. So this is how the bubble sort is going to sort the given numbers. And for example, if you take the algorithm, here there is 2 loops. So now we go with the algorithm in this way. The first loop that runs for 0 to n elements. Let us assume that there are n elements in the given array. So the outer loop goes for n times, and then we have another loop which again runs for the n times. So in this we check the condition for the first element and the next element, that is the a of 0 element. So let us take an example here, assuming that is an array here. So let us consider the first two elements, that is comparing the 0th element and the first element in the array. We need to compare those two elements there. So here we write an if loop inside to compare those two numbers. So we compare the jth element, that is j is given from 0. So we compare the 0th element in the first element, and if they are not in the correct order, that is if the 0th element is greater than the first element, initially we go with the swap operation. We can write another swap function. So this is how the algorithm runs for the bubble sort. So the time complexity for this one is, you can see that the inner loop that is going to run for n times, and the outer loop also, which is written there with I value, that again runs for n times. So the time complexity for this bubble sort algorithm is big O of n square. So this is how the bubble sort works. Then now we go with the another sorting algorithm, which is the selection sort algorithm. Now in the selection sort algorithm, again we go with some example. So let us take the same numbers as the previous example in an array, that is 537 and 164. That is the array we have taken previously. So that is the same array we are taking here. So in this array, so now how does the selection sort work is, we have a variable, we call it as a minimum variable. So we assign a variable called minimum and we write the first element in the array. That is how we declare. So we take the first element and we assume that that is the least element in the array. So let us consider this one as for again ascending order. So we assume that the first element that is found, that is least element. So in this case it will take 5 as the minimum element, and it will compare with the other elements and to know that whether if there are any elements that are lesser than that minimum element. So initially we have taken min equal to 5, and it compares with the next element, that is a of 1. So where we have the 3 value there. So it compares which is the least element, whether it is the current minimum value or the element that is it is comparing. So now 3 is the least element. So now it will take the index of 3, that is 1, right. So the first element, that is the array, the first element in the array 5 is greater than 3. So 3 is the least element now. Now again it compares for the next element, that is 7, that is in a of 2. But comparing with 7, the least element is still 3, so it doesn't change its index. Then again it compares with the next element, that is a of 3 there. Now a of 3 is less than the current minimum element, so it will change the index to 3, where the value is equal to 1. And then it again compares with the next element, that is a of 4, where we have 6, but the minimum element here is 1. So again it compares to the next one, and so on. So after completing the one iteration, we get the index of the least element here, that is 3, where the value is 1. So it swaps with the first element. So it actually swaps the value in A of 0 with the value in A of 3. So those two elements will be swapped. So after the first iteration here in selection sort, the least element will be in its position. So after swapping the 5 and 1, that is the resultant array. So that is the result after the first iteration. Similarly, next iteration will go with the minimum element comparing the second one with the remaining rest of them. That is, now we take minimum equal to A of 1, which is equal to 3, and compare with the next elements to find the next least element, and so on. It works for the other n times, and finally the array is sorted. This is how the selection sort works. Again, the algorithm for this one is also taking the time complexity of n square elements, n square number of times. So the time complexity is, in the worst case, it will take again big of n square. So this is how the selection sort works out. And comparing these two algorithms, bubble sort and selection sort, they follow the brute force technique, that is the straightforward approach, and both of them have the same time complexity. So we haven't discussed all the iterations for the selection sort. I guess you can understand after the first iteration. Similarly, all the n iterations will go with the same way. And the algorithm is also given in the textbook, which you can go through easily. So now we go with the next one, which is the searching technique. So linear search or the selection sequential search, we call it as, is a basic searching technique where the array of n elements are given and we need to search for a key element and finally return the position at which that element is present. If not, we present that the element is not present. So again, this is a straightforward approach followed in this brute force technique. So let us take an example here. So I have taken 6 elements in the array, that is 41, 55, 36, 24, 19 and 39. So these are the list of elements that are present. So I am taking 6 elements. Now my key element will be 19. Assume that my key element is 19 and I have given the values of the array also. At A of 0 it is 41 and so on. So now in linear search, what is the algorithm is? It will search for 19 and it return the position. So definitely we can know the answer that it is 4. The linear search algorithm should return the value 4 here. At the A of 4 we are having that, or else the 5th position we have that element 19. So how we write the algorithm here is, again it's a straightforward approach. So we'll write a for loop here. So for every element of I, we check that if A of I is equal to key, and if it is equal, we will return I. And else, we haven't written the else case here. If at all we don't find any element that is equal to the given key in the array, so simply we return that we don't find that element. So but this is a very straightforward approach. We search all the elements from first to the last. So assume that there are 100 elements in an array. The best case is you can find the element in the first position itself. So always the best case for the quick sort, the linear search is big of n1. So we find the element at the first position itself, then we call it as the best case, that is big of 1. And in the worst case, you can find the element at the end of the list, the last element. So then what happens is we search the n elements. So the time complexity is big of n there, that is the worst case for the linear search. So this is how the linear search works. Then we go with the next searching technique in the brute force, that is string matching, which is also coming under the searching techniques. So that's also a very easy technique. So similar to the linear search where we search for an element in the set of elements, in string matching the concept here is we are given a text of some n characters. Assume that the length of the text is m characters and there is a pattern given which is called P, which is having the length of n, and where always m is greater than or equal to n, that is the size of the text is greater than the pattern length. So we assume that the length of t, that is mod t, is equal to m and the length of the pattern is p, mod t is equal to n. So always m is greater than n, so the text should be greater than the pattern. Now we check whether this pattern is present in the given text or not. So for example, we have taken an example, the text is equal to every day is good, so it is having some characters here including the spaces there, and let me take the pattern as day. So now we want to check whether that pattern P is present in the text or not. So we can see that it is clearly present there. So in brute force technique it is a straightforward approach. So what we do is we check each letter comparing with the text and the pattern like this way, and once it is not matched, it goes to the next position. So the pattern is moved to one bit to the right hand side, and again checks with the next three letters there in the text, and so on. After few steps we get the answer at some location, and the algorithm returns the position at which we found the given pattern in the text. So this is almost similar to the previous method what we have seen, that is linear search, where you search for one number in the given set of numbers. Here we check for a pattern or a word or else some small text in the given message or else a text. So this is called as string matching. Later we compare this with the other methods which are more efficient than searching, because this is brute force technique, it takes more time. So there are few more methods in the upcoming chapters where we call it as Boyer-Moore or Horspool methods. So they will be seen in the next chapters. So these are the following techniques we have seen so far in the brute force technique. In the next video we will be seeing the other examples in brute force technique, which are closest pair, convex cell, and also the exhaustive search techniques, that is traveling salesman problem, knapsack problem and assignment problem. So these 5 will be again checking in the next video, which will conclude the brute force technique. So we see how the closest pair and convex cell problem is solved in the brute force technique in the next video, and those two problems are also again solved in the divide and conquer approach in the later videos. So in the next video we will discuss these two problems as well as the traveling salesman, knapsack and assignment problem. Thank you all. We will meet in the next video.